So hello everyone, hope you're doing really good and welcome back to my channel. Today we are at day 7 of the July daily Leetcode challenge and we again have a medium level question in front of us. From the last few days we had some different questions, but today's question is very different because here on we will be doing questions based on the binary search, and in this particular question we also have the application of sliding window. We'll see that, but let's see the question first. First see the inputs. We are given an answer key array which has, I can say that boolean values, true and false values, only true and false values. Okay, so and the other input is integer k. Okay, so we are talking about a confusion here and we are talking about exam here. What are these terms? Let us see now. A teacher is writing, basically a teacher is preparing a test which has n true and false questions. Okay, so there are n true and false questions with t denoting the true and f denoting the false. So this is the notation which we'll be using, capital T and capital F. Okay, he wants to confuse the students by maximizing the number of consecutive questions with the same answer. Please pay attention here. He wants to confuse the students by maximizing the number of consecutive questions with same answer. Okay, that means I want as many questions to be, for example, if I'm starting from true, I want as many questions as possible to be true. Okay, because see example here, instead to here there are two truths and there are two truths here and there are n more truths. So what is happening is in between them there are false. Okay, so if we could, the ideal solution will be if we can club all these truths together. Okay, all the truths will come together. That's what they're trying to call here as a confusion. Okay, so the teacher wants to confuse the students by maximizing the number of consecutive questions with same answer. Okay, multiple truths or multiple false in a row. Please pay attention here. This is the actual question. Okay, if you understand this part, you will understand the theory of this question. Okay, now you are given a string answer keys. Okay, as you can see here, it's not in the form of array. Basically, it's in the form of a string. Okay, you're given a string answer key where answer key of I is the original answer to the ith question. Okay, for example, this is the answer to the first question and so on. Okay, in addition, you are given integer k, the maximum number of times you can perform the following operation. So we can perform a operation this many number of times, but what is the operation? We are yet to see that. Okay, change the answer key for any question to true or f, so that is true or false. That is set answer key of y to true or f. What they're trying to say is, see, we can change, for example, case 2 here, so we can change any two values. Okay, for example, this f I can make it as a true, this f I can make it as a true. Okay, similarly this t I can make it as a false. So basically I can reverse any two I can basically swap or reverse any two indices. Okay, that's what it is, because 2 is here. Okay, so what see, after reversing, what I need to ensure, I need to ensure that return the maximum number of consecutive t's or F's in the answer after performing the operation at most k times. So let me break this question very, very, very easy way for you. See, what we have to do is I have to change any two places. Okay, it need not be two. See, it can be even less than two. Okay, for example, see, suppose there are three t's present. Okay, there are three twos present, and only one f is there. Then we can just change that f. Okay, so this whole two need not be utilized. Okay, this is not a must. It's just an option for you. Okay, at most, see, there's the maximum number of times you can see. Please read the question properly. This is the maximum number of times. Okay, so at most we can change two places. What we have to ensure after changing two places, we have to ensure that the maximum, okay, the group of truths and or the group of false has the maximum consecutive truths or false. That's what we have to ensure. The maximum number of consecutive truths. See, I think you will see understand this only after seeing the question. So basically, I need to see in this question. I need to ensure that at least I have the maximum number of truths or have the maximum number of false together consecutively. Okay. So what I can do, I can change these two f's to true. Okay. So what I will have four truths. Okay. So the answer here is four. Coming to the second example, I can change only one answer. Okay. So what I will do is I will make this 2 as a f. Okay. Or I can make this t as a f. So any one thing we can do. Okay. So I will have three d's ultimately in whichever way you do. So ultimately the answer will be three. Coming to the third example, here also we can change only one place. Okay. Only one swap is possible. So what I can do is I can make this f as a true. So I will have five truths at once. Okay. Similarly, this also can be made as a true. So this five will be possible. So total answer is going to be five. That's what the answer is. So this is the question. You can try a brute force approach for this, but let me tell you this very frankly. See the n, the range of n. Definitely, a brute force approach is not going to work here. Okay. So n square approach or anything more than that, it won't work here basically. Okay. So what we are going to code is we are going to code a binary search approach. In that binary search approach, in each iteration, we will be using a O of n approach to see if it leads to a a valid answer. Okay, so yeah, let me make these things very clear to you. We'll be using a sliding window approach basically. See, what idea here is, see, one thing you will be noticing is that the answer which you are seeing here, okay, please pay attention to what I'm saying. These are the hints for you to get this kind of code which I'm going to show you. See, the answer is going to be between either this k or the maximum of this length. Okay, what that is, the answer will be one number between the length of the answer key or two. Okay, so the min will be this. See, why I'm saying is, for example, see, if I take any two characters, okay, any two consecutive characters, definitely I can change them, okay, because of this, okay. So definitely the minimum answer possible is going to be my k, okay. The minimum answer possible is going to be my k, and the maximum possible answer, that is the range of the answer, is going to be between k and length, okay. What I'm trying to say, the maximum answer, that is the length, the range of the answer is going to be between k and the length, okay. That's what I'm trying to say. That's what we are going to do. We will do a binary search between this length. Okay. So the left will start from k and the right will start from n. Okay. We are going to do a basic binary search. It's again I want to say one thing, that if you are not sure what a binary search is, please go and search it in the Wikipedia or the Google or whichever site geeks for geeks, anything you can do. So this is the basic template of a binary search. Okay. I'll just highlight this and show you. This is just the basic template of a binary search. Okay. What we'll do is we'll fix the left and right first. Okay, in this case the left is going to be k, because k is the smallest possible answer possible, and our right is going to be n, because our answer can be n. Okay, there is no guarantee that n will be the answer. We are just saying that the range of the answer is between k and n. Okay, with k being included. Okay, remember, k is also included. K is definitely answer, but we want the maximal answer, right? K also is going to satisfy all the conditions, but we want a maximal answer, right? Yeah. So this is the basic thing. Okay. Till left is less than right, this will be executed. We'll find the mid between left and right. Okay. See, these things I am hoping that you will be knowing. See, this kind of, it's called an integer division. We want a number between left and right. Okay. The midmost. Okay. For example, if left is 6 and right is, let us say, 8, so we want 7. Okay. That's what it is. The middle number between left and right. Okay. I will check that if a window of that particular size, that is this size, okay, if a window of this size can satisfy this condition or not, okay. That is a window. For example, if a window of size 3 can satisfy this condition or not, okay. See, similarly, as you can see here, in this case a window of size 5 is possible, okay. If I, that is size 5 is possible, means I can have a window in which all of the answers are going to be only one, okay, only one true or only one false. That is, all of them are going to be true or all of them are going to false. Such a window is possible or not, I'm going to see. The windows length should be this, okay. This I'm what I'm passing, start sliding window. I start a window with this length, then I will be moving it to the right till the end of the array, and I will see that any instance of this such a thing is possible or not. Okay, a window full of trues or false. That was it is, okay. If it is possible, then I will be, the basic stuff of the binary search. See, if it is possible, my left will change, then this will become my limit, okay. The left will become mid and the right will remain the same. If this is not true, then again the limit will change, left will remain the same and right will become mid minus 1, okay. That's what it is, okay. And finally, we'll return left, because you can see in all the cases, I am assigning left only those things which are already answer, okay, which are already a probable answer. For example, here I assigned k, okay. Here I assigned k, and here I am assigning mid, which is already answer, okay. If mid is true only, then it will come here, okay. Now coming to how the sliding window will be executed. So it's very simple. I am simply creating a dictionary. Okay, I am assigning true and f as a value. Okay, so true and f as a keys, and their values are going to be their counts, and initially it will be 0. Okay, so this step is placing the initial window of size. Okay, just the initial step. That means, see, size is, for example, if I want to place a window of 4, means I will take the first 4 elements. Okay, I will take the first 4 elements and try to see if I can make k modifications and make all of them as true or all of them as false. That's what I'm going to check initially. Okay, so I will take the first size elements, that is 0 to size minus 1. I will take, okay. What I will do is, when I get element, I will increase its value in the dictionary. Okay, this t will be basically increased, and the value of this t will be increased. Okay, then after I come out of this loop, okay, after I come out of this loop, what I would have done, see, for example, size 4 means I would have covered the first 4. That is, if I get a t, I will increase its count by 1. If I get a false, I will increase its count by 1. Okay, this is a dictionary in Python, right? After that, I will check if the minimum of the each of them. Okay, the minimum of a. See, this I'm checking if minimum of the count of t or the minimum of the count of f. Okay, if it is less than or equal to k, then return true. What it means is that, see, for example, if the count of t is the minimum, okay, t is the minimum. That means f is in majority. Okay, so I have to convert t to f. Okay, because t is in minority. So I'm just checking how many t's I can convert. Okay, so if the count of t is less than or equal to k, okay, if it is less than or equal to k, that means all of them can be converted to f. Please understand what I'm saying. I will again repeat. Let us assume that T is the minority. Okay, that means most of them are F in the window. Okay, current window which I have placed, in which we have taken the first size number of elements. Okay, first, see, size is an integer. First size number of elements I have taken. Okay, what I'm saying is, let us assume that T is the minority and F is the majority among them. Okay, so the minority should be converted to a majority. For that, I need to convert all the trues to false. Okay, so I'm checking if the number of trues is less than or equal to k, because only k conversions are allowed, right? Only k conversions are allowed. I'm just checking if it is less than or equal to k. If it is so, then I will convert them. So if they are convertible, then I can return true. See, if the size of the minority is greater than or equal to k, then it's not possible. Okay, sorry, if the size is exactly greater than k, strictly greater than k, then it's not possible to convert all of them. Okay, that's what I'm trying to say. After the first step, that is, see, this whatever we are doing is for 0 to size minus 1 elements. Okay, then we will start another loop for size to n elements. Okay, size to n minus 1 elements. This is for 0 to size minus 1. This is for size to n minus 1. Okay, again same thing we are doing, but this time the window will slide. Okay, the window will slide towards the right. Okay, I will take the next, see, for example, if this is the first instance of window, that is the first three elements, then I will take the next three elements. Okay, you can see the first element is removed, another element is included. Similarly, next time we'll take another three elements. Okay, similarly, the next time we'll take another three elements. This is what we are going to do. So what we are going to do, we are going to add another element. So I will add its count also. So which is, suppose it's a true, I will add in the value of true, I will add, and that is, I will increase its value by 1. I will add its frequency by 1. Okay, and the first element will be removed. For example, see, uh, this is the window, means the first t is now being removed from the filter. Okay, so only the filter is now like this. Okay, the filter is now like this. Okay, so we have to reduce the frequency of the first t. Okay, that's why we are doing a minus here basically. Okay, this we are doing as a minus. That is, I minus size element should be removed and ith element should be included. Okay, where I is the size element. Okay, starting from size. So again, after every, such insertion, that is after every instance of the the window, I am checking if the current window, if the minority has a frequency less than equal to k. If it has a frequency less than equal to k, definitely I can do that. Okay, I can convert those minority into minor. That is, convert those minority into majority. If I can, see, the idea here is, if a window has all the elements of one type, okay, all the elements of one type, then definitely I have to return true for it. Okay, this function will return true for that. Okay, if that is not possible, only then I will return false. So you can see that we are having two instances where we are returning true. Okay, that both instances have the same code. That means if at any instance of the window we have all the elements of the same type, then we have to return true. If none of those that is possible, we have to return false. And how to ensure that we are doing the proper conversion? We are checking if the minority is less than equal to k or not. If it is less than equal to k, definitely we can convert them. Okay, otherwise we are returning false. So this is the code we are. And if you can see, this is going to be off login approach because it's a binary search. And for each the iteration of this, we are calling this function. Okay, so what are these functions? Time complexity, so often. So basically the total time complexity of the solution is of n log n. So I hope you have understood what it is. I will again repeat. See, basically the size of the window which is going to make it possible, that is the maximum size of the window, that's what they're talking here, maximum number of consecutive keys. This I'm trying to take, time track using a sliding window approach. Okay, so what will be the size of the window? That, see, the answer, that is the size of the window which will be the answer, is going to be of length between this k and the length of this. Okay, any number between these two, it will be that. Okay, that will be the answer. So I have started my binary search using these these constraints. Left to is equal to k and right is equal to n. Then I'm doing the simple binary search. I'm calculating the mid, and for that mid, that mid is going to be the size of the window which I'm going to check. Okay, that's what I'm checking here basically. If I get true, that means I will reduce the size. Okay, if I get true, that means the new size will be, left will be changed to mid, right will remain the same. If I get a false, that means the size should be even smaller, so the right will change and the left will remain the same, and such things will be continued till the left is less than equal to right. Okay, once this condition breaks, we have to return the left. Why we are reading the left? Remember, whichever time we are assigning the left, it's always an answer. Okay, this mid is also an answer because it's returning true, right? So we're assigning that to the left. And similarly here, k is also probable answer, and that we're assigning to left initially. Okay, so k always has an assignment which is a real answer. Okay, but as the question mentions, we have written the maximum such among all the probable answers. We have written the maximum, right? So that's what we're doing in the binary search. So in the binary search, we are fixing the size of the window, and using this function, we are executing to see if that particular that if a window of that size can have all the elements of one type or not. Okay, true or false. That's what it is returning. So yeah, friend, it's a solution of n log n. I hope you would have enjoyed the solution. Yeah, I hope there won't be any doubts. If you have any, please do comment below, and we'll see you again tomorrow. Okay, thanks a lot.